In the last video, you have learned how to write electronic configuration of an atom. In this video, we will try to explain how to write the electronic configuration of an atom, of an ion, or of an atom which is in an excited state. Let's say, for example, sodium. The atomic number of sodium is 11. You know very well that the atomic number is equivalent to its number of protons. And since an atom is electrically neutral, the number of electron and proton is the same, meaning to say the number of electron for sodium is also 11. In the first example, we have its electronic configuration as an atom: 1s2, 2s2, 2p6, and 3s1. So we have a total of 11 electrons. So that's how you write the electronic configuration of sodium as an atom. Now this time, if you are asked to write the electronic configuration of sodium as an ion, this will be its electronic configuration. The second example, you will write it as 1s2, 2s2, 2p6. There are only 6, 7, 8, 9, 10. There are only 10 electrons, meaning to say one of its electron was already given off. It might be transferred to another ion, but it does not mean that the entire atom was changed totally into another form, because the number of proton is still 11. So the new electronic configuration would be 1s2, 2s2, 2p6. The last one is the electronic configuration if an atom is in its excited state. When an atom is in its excited state, one electron jumps off to another energy level, into much higher energy level. So it could be like this: 1s2, 2s2, 2p5, and then one of its electron jump off to the next energy level, which is 3s2, formerly which is 3s1. It became 3s2. It is not a wrong electronic configuration, it's just in its excited state, meaning this electron can also jump up here, and this electron can also jump off in this level, just to show that it is in its excited state. Let's try another example. Before we proceed to the next example, there is another method of writing the electronic configuration of an atom. The short way of writing the electronic configuration of an atom. You know very well that in the periodic table we have a group of elements called the noble gases. These noble gases has a configuration which enables them to bond with other elements, which we will be discussing in the next videos. So in this case, the shorthand method for sodium would be like this. You need to know first the noble gas before sodium. So let me show you by having the periodic table first. Okay, so sodium is 11. So prior to that, we have the element neon, which is under the noble gases. The violet ones are the group of noble gases in the periodic table. So 10 is the atomic number for neon, and 11 is for sodium. So it's just fitting to use neon instead of argon, because argon is already 18 while neon is 10. So we will get the symbol for neon here. Okay, you will use that symbol, signifying that it follows the electronic configuration for neon, which is 1s2, 2s2, 2p6, and then you will add here 3s1. So that's what we call the noble gas electronic configuration, because it uses the electronic configuration of the noble gases. Let's have another example. Now this time, let's try to have the element. Okay, wait. right? Let's try to have the element potassium. Potassium is symbolized by the letter K, and its um, atomic number is 19. So let us try to write its electronic configuration. So we have 1s2, 2s2, 2p6, 3s2, and then after that, what else? 3s2, 3p6, and then 4s1, followed by, okay, I guess that would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, so that's how you write the electronic configuration of potassium as an atom. Now, if you are asked to write the electronic configuration of potassium as an ion, you are going to write this one. 1s2, 2s2, 2p6, 3s2, 3p6, and then let me see, 6, 7. Okay, the 4s1 will be removed from its electronic configuration because potassium tends to give one electron to another atom for it to be stable. So this is now the ionic form of potassium when you write its electronic configuration. Now for its excited state, it could be 1s1, 2s2, 1s1, it could be 1s2, 2s1, 2p, 2p6, 3s2, and then something like that. So in this case, in order for us to make it clearer, let's just use the last energy level. So 1s2, 2s2, 2p6, 3s2, 3p5, 4s1. Excited state. Let me just have the shortcut ES. That means excited state. Now, how do we write the noble gas electronic configuration for sodium? You need to go back to your periodic table of elements. So since we have potassium, the noble gas before potassium is argon, which is 18. So we will write the symbol for argon. We have Ar. Since Ar is 18, just have to write 4s1, making it potassium, and that is now the noble gas configuration, noble gas electronic configuration for the element potassium. So that is just how to write the electronic configuration of potassium in different forms. Now there are also hidden meaning in our electronic configuration. Now let's take 4s1 for example. The 4 represents the energy level. The S represents the orbital, while the 1 represents the electron. Okay, so let's take potassium for example. So I want to have the electronic configuration of potassium in its atomic form, and then we will try to see what is nawala. Potassium is 19. Okay, so let me just rewrite the electronic configuration for potassium. So 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. So 10, 16, 17, 18, 19. Okay, so as I was saying a while ago, these numbers has meaning. The one here means the energy level. The S is the orbital, while the 2 is the electrons. These are very important in order for you to know its atomic structure. So how do we draw the atomic structure of an element? So let's go back to potassium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So this is the atomic structure of the element potassium. So let's count first the energy levels in the element. So we have number 1, meaning to say we have the first energy level. We have 2, 1 and 2, meaning to say it's in the second energy level. We also have both 3, meaning to say we have third energy level, and we have the 4, which is the fourth energy level. If we are going to draw the atomic structure of potassium, we have here the nucleus. Let's just write the letter K, which symbolizes the element potassium. So we have one energy level, the first energy level here, meaning the first energy level has 2 electrons, 1 and 2. The second energy level has 6 plus 2, how many? So there are already 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. In the third energy level, there are also 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. And in the last energy level, there is only 1 electron. So it's here. It could be drawn in this manner or can be drawn in this manner too. In the first energy level, we have 2 electrons. In the second energy level, we have 8 electrons. In the third energy level, we have 8 electrons. And in the last energy level, we have 1 electron. So that's just the same. It's just that this uses only little space of your paper. Now this, at the last portion, is what we call valence electron. When we say valence electron, it is the electron found at the outermost energy level of an atom. So in this case, the outermost energy level is 4, which has 1 electron, and that means the valence electron is only 1, since it is found at the last energy level. So hope you get it correctly.